In all types of machines, the moving parts rub against each other, and this offers a resistance, and this is known as friction. Friction causes wear and tear of the parts. So what happens is that energy is wasted because of this friction, and thereby the efficiency of the engine or the machine decreases. So the output is low than expected. Hence, steps should be taken in order to avoid or reduce friction. So certain materials are employed to reduce friction, and these are known as lubricants. So we can define a lubricant as a substance or a material which reduces friction when applied at the rubbing parts of the machines. Okay. And lubrication is a process of reducing the friction using a lubricant. Coming to the functions of a lubricant, it prevents direct contact between the moving parts. So this reduces wear and tear. Second function is lubricants reduce wastage of energy. Therefore, what happens is that the efficiency is enhanced. Third, it reduces frictional heat, and this prevents expansion of the metal. In machines, when metal surfaces are rubbing against each other, it produces a lot of friction and heat. The frictional heat can be removed by lubricants, or lubricants act as coolant by removing the frictional heat. The next point is they act as a seal, that is, they prevent the entry of dust and leakage of gases at high pressure. The next function of lubricants is they reduce the maintenance and operation cost of the machine. And the last cost, it minimizes corrosion, which is a very, very dangerous to the machines. So lubricants have got all these functions, 7 functions. Next, we'll see what are the characteristics of a lubricant. The lubricants should be chemically inert. That is, they should withstand oxidation, decomposition, reduction at high temperatures. Then only they can function as a lubricant. The second point, they should have a high flash point and fire point. Then the operating temperature should be well above the operating temperature. Third, they should have a high viscosity index. That is, these lubricants should be highly viscous. Then only they can function effectively as a lubricant. And the next point is they should not corrode the machine. They themselves should not have any corrosive effect on the machine. Emulsions can be classified into 4 groups based on their physical state. The first one is liquid lubricants, and there are various examples of liquid lubricants. The first one is vegetable oils. Vegetable oils like castor oil, etc. are used as lubricants, and these are from vegetable origin. Second one is from animals. Example, whale oil. This is also used as a lubricant. Third, mineral oil. That is when we separate petroleum into various fractions. Some fractions are used as lubricants due to high viscosity and other properties which suit for lubrication. Then the fourth class is synthetic lubricants. These are prepared artificially or it is man-made. Example, silicones. Silicones are used as lubricants. Then the next class is blended or compounded oils. That is mineral oils mixed with certain additives, that is some other materials, and that are used as lubricants. Then coming to the second class of lubricants, these are semi-solid in nature. Example, greases and vaselines. They are neither pure solids nor pure liquids, and they can function as lubricants. Third, we come to solid lubricants. the most well-known example is graphite. It is nothing but a form of carbon, and this is also used as a very good lubricant. And molybdenum disulfide, this is another solid material which is also used as a lubricant. Next we come to emulsions, that is, this contains example, oil in water or water in oil. That is, one will be the dispersed phase and another will be the dispersed medium. And so this is there are two types in this, and these are also used as lubricants. Now we'll deal with liquid lubricants. These are also known as lube oil. Now first we'll see about the vegetable and animal oils. Actually, these vegetable oils are nothing but glycerides of glycerol and higher fatty acids. That is, they are nothing but esters. The functional group present is esters. Now these are used, but they cannot be used effectively because they undergo oxidation at very high temperatures. Now, as a result of this oxidation, you get gummy products which are not desirable. And also, presence of water will hydrolyze these glycerides. You know that esters undergo easy hydrolysis. So what happens that they get hydrolyzed, and so the oil will no longer remain as oil but undergo hydrolysis to give you ester. Ester hydrolysis give you alcohol, that is the glycerol, and acid. This is also not desirable. So these are used as blending agents with other lubricants. Mineral oils or petroleum oils can be used as lubricants. When crude petroleum is subject to fractional distillation, we get various fractions. The fraction which contains carbon atom from 12 to 50, this fraction is highly useful for lubricant action. So this is used for lubrication purposes. There are various reasons why this fraction is utilized for lubricating purposes, because it is cheap. Second, it is very stable. And third, the oiliness can be improved with help of vegetable oils or animal oils. Okay. The mineral oil contains wax, asphalt, and other oxidizable impurities. So this mineral oil as such cannot be used as a lubricant. It has to be subject to various treatments to remove these unwanted impurities. Now this removal of wax, asphalt, etc. involves various steps. We'll see one by one. The first step is to remove the wax. This wax at low temperature can crystallize out or come out of the oil, but this is done by a method what we call as dewaxing process. In the dewaxing process, petroleum oil is treated with a solvent that may be propane or trichloroethylene. Either one of these two can be used as a solvent, and so it is well mixed and cooled. When it is cooled, the wax will crystallize out, which can be filtered and removed. So the first step removes the wax. The second step is the removal of asphalt. If we don't remove the asphalt, asphalt will leave carbon deposits on engine parts, which is not desirable. So this asphalt can be removed by a technique known as acid refining process. The dewaxed mineral oil is treated with concentrated sulfuric acid and agitated. When a sludge is obtained, this sludge can be removed by filtration. Next, the mineral oil is treated with sodium hydroxide to neutralize the unreacted concentrated sulfuric acid. The third step involves the removal of sulfur, and this process is known as desulfurization. And what happens is that the oil plus nickel plus hydrogen, they are subjected to a process known as hydrogenation. That is, the oil will be containing some unsaturation and the hydrogen will be added, so you get a saturated compound. The next step involves the removal of colored substances, colored impurities, and also this microcrystalline waxes. Wax will be in very small, very micro form. These can be removed by filtration through material known as fuller earth. So these are the 4 steps by which you can remove the unwanted materials, and the mineral oil can be used effectively as a lubricant. Now next we'll come to synthetic lubricants. The synthetic lubricants are finding use in the temperature range minus 50 degrees to minus 250 degrees centigrade, and also at higher temperature. See, as in aircrafts they'll be using lubricants. The lubricants are pumped at minus 50 degrees centigrade. But during the takeoff and landing, the same lubricants can get heated up to 120 degree centigrade or even up to 150 degrees centigrade. So if you are going to use petroleum oils at this particular temperature, they can get easily oxidized. Next we'll see synthetic lubricants. Synthetic lubricants are those prepared or manufactured and being used for lubrication purposes. See, in this range from minus 50 degree to 250 degrees centigrade, some lubricants are needed, and so these lubricants should be able to function effectively within this range. Let's take for example this aircrafts. The lubricants are pumped at minus 50 degrees centigrade, but what happens that during the takeoff and landing, the temperature raises to 120 degrees centigrade, or even it may reach 150 degrees centigrade. Suppose petroleum oils are employed for this purpose, what happens that at this temperature range they can get easily oxidized, and at this temperature range minus 50 degrees centigrade, the waxes present in the petroleum oils can easily separate out. So what happens? This causes a lot of problems. So there was a necessity to find another lubricant which can effectively operate as an lubricant within this range. And so silicones and polyglycol ethers, these are polymeric in nature. Silicone contain the linkage silicon argon silicon, and polyglycol ethers contain this linkage, carbon oxygen carbon linkage. So these materials can withstand very high temperature and also very low temperature, and these are employed as lubricants, especially in aircraft. The next class of lubricants is blended or compounded lubricants. What are these blended lubricants? Lubricant oil is mixed with certain materials known as additives, so that they form an oil which is known as blended oil, or these have got some better properties than the lubricating oil. So that's why we add these additives. For example, suppose an additive is added which is known as oiliness carrier. If this is added, then that will increase the oiliness or adhering properties of the lubricant. Example, fatty acids, long chain fatty acids like stearic acid and palmitic acid. Then there are certain additives known as extreme pressure additives. When these are added to the lubricating oil, that will form a metal surface film of low shear strength, and that film has got a very high melting point. Example, organic compounds containing chlorine, sulfur and phosphorus are used for this purpose. The next type of additive is viscosity index improvers. These, when added to the oils, they prevent thinning of oils at higher temperatures and thickening at lower temperatures. Example of viscosity index improvers are N-hexanol, an alcohol, and polyisobutylene, this is a polymer. Next, pour point depressions. That is, these when added to the oil, the lubricants, they prevent separation of wax. Example, phenols. The next additive is thickeners. These are added so that the viscosity of the lubricant is increased. That is, the resistance to flow will be increased. Example, polyester, polystyrene. These are polymeric in nature and these can function effectively as thickeners. The next type of additives is antioxidants. Antioxidants are those which retards oxidation. That is, when they are added to the lubricants, they retard oxidation and prevent formation of gums. Once the lubricant gets oxidized, you get some products which can form a gum. This will be retarded. And the materials used are phenolic and aromatic amino compounds. Then there is another class of additives that is known as deflocculants and detergent deposit inhibitors. They prevent carbon deposition, which can block the passage of oil. So that can be minimized or prevented totally by the use of substance like sulfonates, that is substance derived from sulfonic acids, and salts of phenols. The last class of additives are known as corrosion inhibitors or corrosion preventers. Compounds containing antimony and phosphorus are used effectively for this purpose. Actually, they are adsorbed on the metal surfaces and they protect the surface from the attack of moisture. Otherwise, the moisture can corrode the metal. So these are known as corrosion preventers or inhibitors. The next class of lubricants based on their physical state is the semi-solid lubricants. Example, greases. Now we'll see how these greases are prepared. Actually, the lubricating oil is mixed with metallic soaps and this is thickened to give grease. This is the general way of preparing greases. Generally, vegetable oils are taken and it is saponified or it is subject to hydrolysis using a base of general formula MOH. M can be sodium, lithium, or even calcium hydroxide can be employed for the hydrolysis purpose. Now, this contains ester function. The ester will undergo hydrolysis to give you alcohol and the acid. The acid will be in the form of the salt. Suppose you're taking sodium hydroxide, it will be in the form of sodium salt. Suppose you're taking lithium, it will be in the form of lithium salt. And this free glycerol alcohol will be obtained. Now, this metallic soap can be used as a thickener. For example, suppose lithium grease is to be prepared. Now, this can be prepared in two steps. The first step involves the preparation of the metal soap, namely lithium soap. This can be obtained from vegetable oils or vegetable fats by saponifying it with lithium hydroxide. When this undergoes saponification, lithium soap is obtained. The next step is to take the lubricating oil and that is treated with the lithium soap and that is processed so that a thickened oil is obtained. So this is the in general the preparation of greases. The chemical nature of the soap determines the various properties of the grease. First, it determines the temperature of usage of a grease. That is the range of temperature within which the grease can be used. Second, whether it can act as a thickener or not. Then the water resistance and oxidation resistance of the grease is determined by the chemical nature of the soap. Then it also determines whether the grease can stick to the metal surface firmly or not. Now next we'll see the types of greases, the properties and its application. Now suppose the soap used is a sodium soap, then the grease is known as sodium soap grease. Actually these are slightly soluble in water and they can be used up to 175 degrees centigrade, and they are mainly used in ball bearings. The second type of grease is calcium soap grease. Here the metal is calcium. Now this is water resistant, but beyond 70 degrees centigrade the soap separates into soap and the grease separates into soap and oil. It is used for lubricating water pumps, tractors, etc. The third type of grease is barium soap grease. Here the metal atom is barium, and this shows resistance to water and it has very good adhesiveness. Actually this is used for lubricating automobiles. The next is the lithium soap grease. Lithium soap grease are resistant to water as well as heat, and these are used even at low temperatures in engines. The next class of grease is aluminum soap grease. This has got very good adhesiveness and also it is water resistant, and this is used for lubricating chains. The next class of grease is axle grease, or this is also known as resin grease. This is very cheap and it has got a very high resistance to water, and therefore it is used in less delicate equipments under high and low speed. So these are the 6 class of greases. Next we'll see the situations where greases are used. Greases are used where oil is squeezed out due to heavier or low load. Under these conditions, greases are used. Second, it is used where in bearings and gears which operate at high temperature, so that will reduce the friction. The third situation is when bearings are needed to be sealed against the entry of dirt and dust. This will spoil the functioning of bearings. So under these conditions, greases are employed. And lastly, frequent application of lubricant is inconvenient in say automobile wheel bearings. There also this grease are applied. The third class of lubricants are the solid lubricants. At normal temperatures they are solid in nature, and these are employed where the operating temperature is too high and also the load is too high, and in situation where the contamination of the lube oil and greases by dirt should be avoided, and also in situation where the combustible lubricants must be avoided. Okay. The most commonly used solid lubricants are graphites and molybdenum disulfide. Among the most important solid lubricants, graphite is very, very important. We'll see the structure of graphite. Graphite is nothing but carbon. The carbons are linked to one another by strong covalent bonds, and they form hexagonal structure like this, and all these hexagons put together form sheets. Now this there are different sheets, one on the top of the other, and these are held by weak van der Waals forces, whereas the atoms within the sheets are held by strong covalent bonds. Now this distance between the two carbon atoms is 1.42 angstrom units, whereas the distance between the layers is 3.41 angstrom units. Now these layers are like plates, and they can slide one over the other because they are held by weak van der Waals forces. So this makes graphite a very good lubricant. Graphite can be used up to 375 degrees centigrade, above which it gets oxidized. Now this can be used as a solid or a colloidal dispersion. A colloidal dispersion of graphite dispersed in water is known as aqua dag, whereas graphite dispersed in oil is known as oil dag. Coming to the uses of this graphite, oil dag is used in internal combustion engines, whereas aqua dag is used in air compressors. And the graphite as such is used as a lubricant in lathes and in open gears. The second important solid lubricant is molybdenum disulfide. Actually, this contains a sandwich structure. Sandwich structure means that is you got different layers. One layer is sandwiched between two other structures of a different atom. Example, see, this is a structure containing only sulfur atoms. So this forms a layer. All the sulfur atoms are linked together by strong covalent force of attraction. The next layer contains molybdenum. The molybdenum atoms are forming a sheet-like structure. The next to the molybdenum layer is the sulfur layer again. So this layer is sandwiched between two sulfur layers. Now you see the distance between two sulfur atoms is 3.08 angstrom units, and the layers are linked together by weak van der Waals force of attraction. So what happens is that the layers can slide over one another, and this molybdenum disulfide has got a low coefficient of friction, so this can function effectively as a lubricant. It can be used as a powder or in the colloidal form. It can be used up to say 800 degrees centigrade, above which this gets oxidized. There are two uses of this molybdenum disulfide. Pure molybdenum disulfide is used in vacuum in outer space, and is also used in heavy machinery at high temperature.